Okay, today we're going to talk about characteristics of functions. First thing we're going to talk about is domain and range. Your domain are your x values. You read it like you read a book from left to right. And then you have your range, which is your y values, and it's bottoms up. So we're going to look at how to find domain and range given a function. So if we look at this example, I like to draw lines to help me better see what's going on. Domain is left to right. So I see that the function is going to start here and it ends over on this side. So what's my smallest x value? -1. What's my largest x value? 4. So this is 1, 4. This has a closed dot giving it brackets. This has an open circle giving it a parentheses. If we touch that value, it gets a bracket. So when the function reaches that value, it gets a bracket. It gets a parentheses when it does not. Let's also look at range. Your range is from the bottom up. So we're going to look at our lowest y value, which in this case is -5, to our highest y value, which is 4. We have a closed circle and a closed circle, so both get brackets. Lowest point is -5, highest is 4. So that's how you find domain and range of a function. Let's look. So here's your range. And again, it gets brackets. Let's look at zeros. So a zero of a function, we can say it's called a zero, x-intercept, solution, roots. All of these mean the same thing. And it's just where the function or the graph crosses the x-axis. So if we're trying to find a zero, we're trying to find a solution. Some examples of what you could see. So you can have the function crossing the x-axis twice. You can have it cross the x-axis once. And you can have it not touch the x-axis at all. So this is a quadratic function. Quad meaning 2. We have 2 solutions. When it crosses the x-axis twice, we get 2 real unique solutions. When it crosses once, we're still going to have 2 solutions, but they're going to be the same. And then this does not cross the x-axis at all, so this is going to be 2 imaginary solutions, or not real solutions. And we'll talk about what that means later. But where it crosses the x-axis is going to give us our solution. So if we look at another example, we look at this one, we can see that the function or graph is crossing at 1, 0 and 5, 0. So the x-intercepts are 1, 0 and 5, 0, or our zeros are 1 and 5. Either way. So this is written in coordinate form or just written out the zeros. So our next example, where it crosses the x-axis, it crosses here at -2, but it's just touching. It doesn't go through the x-axis, so it just touches. So this gives us 2 same solutions. So that's why we're writing -2 twice. And then it goes through 3, giving us 1 real solution. The amount of turning points will define what kind of function it is and how many solutions it's going to have. So we see that this function turns once and twice. So we have 2 turns, and you're always going to add 1 to that turning point. So this is a total of 3. This is a cubic function, and it's going to have 3 solutions, which is what we have up here. I can look at the same thing with a quadratic. It has 1 term, so I do 1 term plus 1, giving me 2, making this a quadratic function, and meaning I'm going to have 2 solutions, which is what we have here. So the number of turns will let you know how many solutions you have. So you take the number of turns, add 1, that gives you a number of solutions. If we look at this, how many turning points do we have? We have 1 here and 1 here. So 2 terms plus 1 gives us 3 solutions. So this is a cubic function as well. And we look and see, where does it cross the x-axis? It crosses at -1, 1, and 2. So those are our 3 solutions for our cubic function. Then we look at y-intercepts. This is where the graph crosses the y-axis. So when we look here, so for this example, we're going to look and see, where is the y-axis, or where does the graph cross the y-axis? And it crosses it right down here. It's going by 2, so 2, -4, -6, -8, -10, making this -12. So it intercepts the y-axis at -12, so my coordinate is 0, -12. Now look at this next example. Again, it's going up and down by 2s. So it crosses the y-axis at 2, so it's 0, 2. Then we're going to look at finding domain, range, x-intercepts, and y-intercepts. So putting all of what we've discussed so far together. These should have arrows on them, meaning that they're continuing on. So we see that this function is going down and left to -infinity, and it's going up and right to +infinity. So again, our domain is our x values, and we read it left to right. So my smallest x value is going towards -infinity. So my smallest x value is -infinity, and my largest x value is +infinity. It doesn't stop, it keeps going. We can never reach infinity, so it's going to get parentheses. Our range, again, it's going down towards -infinity and up towards +infinity. So again, it's got the same answer, -infinity to +infinity. You can also write this as all real numbers. Now our x-intercepts, this is when it crosses the function at the x-intercept. So it crosses at -2, again, it's just touching. So it just touches, so it's going to have 2 of the same solutions. So -2, 0, -2, 0. I'm repeating them there, and then it goes through the x-axis at 1, so it's 1 solution here. And again, based on my number of turns will tell me how many solutions I'm going to have. So I have 2 turns plus 1 makes it have 3 solutions. This is a cubic function, and that's how many x-intercepts I have. Then we look and see, where does it cross the y-axis, and it crosses here at -4. So it's 0, -4. Okay, let's do one more example. This has 1 turning point. So 1 turn plus 1 gives me 2 solutions, and this is a quadratic. My domain, I see that this is going to the left, -infinity, and to the right, +infinity. So that's my domain. And my range, my lowest y value is -4, and it touches that, so it gets a bracket. And then it's going all the way up to +infinity. We can't reach that, so it gets a parentheses. Then our zeros is where it crosses the x-axis at -2 and 2. Zeros, if you're doing zeros, you can just write the numbers, not the coordinate. Your y-intercept is also this lowest point, which is 0, -4. All right, another thing we're going to discuss is your intervals of increasing and decreasing. So decreasing, meaning it's going downhill. Increasing, meaning it's going up. And so you again read it left to right. Think about an ant walking on your graph. And then a constant is where it's neither decreasing or increasing. So an example of this. We look at this entire graph. I see that, again, you're reading left to right. And it also helps if you put like a dashed line at every turning point. So anytime something new is happening in this function, I have 2 turning points. So I'm going to have 3 intervals of increasing, decreasing, and so on. So here I'm going up. So it's increasing. And it's going from -infinity, because to the left it's going towards -infinity. There's no stopping point. And it's going up, and here you're only using x values. So what is, and this is why the lines help, what is the x value it stops at? -1. So it's increasing from -infinity to -1. Then we look at decreasing. You see it's decreasing from here to here. So again, I'm only looking at my x values. So where on the x, your x-axis, is it stopping the decreasing? So it's going from -1 to +1. And then I look at my last bit of my function, and here it's going back up. So it's increasing. And again, you're only looking at x values. So it's going from 1 all the way to +infinity. So these are your intervals of increasing and decreasing. Let's look at another one. I see I'm going up here. So it's positive slope. I'm going up from -infinity to 0. Again, only your x values. Then I see what's happening in this next section is just staying constant. And again, only x values from 0 to 2. Then I would look at my last part that's going down from 2 to +infinity. So it's decreasing now. So that's how you find intervals of increasing and decreasing. One more example. Again, if it helps, every time your function changes, you can draw these dashed lines to help you see, how many intervals you're going to have. So I look here, it's going down. So it's decreasing from -infinity to my x value. It's not 1. My x value here is 0. So -infinity to 0. Then I see it's going up. So where does it start going up? When x is 0. And it goes all the way to where x is 2. So from 0 to 2, it is increasing. It's going up. Then I look at this linear piece right here. It's going down from my x value, which is 2, all the way to +infinity. Again, the biggest thing to remember, this is just your x values. Last thing we're going to discuss are your relative and absolute minimums and maximums. So relative minimums are all of your lowest points. So relative minimum are all of my low points. So all of my dips. Relative maximum are all of my high points. Then we have absolute minimum and maximum, and this is if we have a quadratic. This is my absolute minimum. Here, because it's going towards positive infinity and negative infinity, I don't have any absolutes, but if I have a quadratic, or if I have a quartic function, This would have either 2 or 1 absolute minimums depending on what the graph looks like. But because it's going towards positive infinity and negative infinity, this does not have any absolute because you're looking for the lowest or the highest points. So let's look at an example. Here, it's going towards negative infinity and towards positive infinity, so I'm not going to have any absolute, but I am going to have relatives. This is a high point, so it's a relative maximum. And this is a low point, so it's a relative minimum. So my relative minimum is 1, -2. My relative maximum is -1, 2. So let's put this all together. So everything we've discussed so far, we're going to look at a problem. So our domain, again, is our x values, left to right. I see that it's going from negative infinity to positive infinity. And my range is the same. I go bottoms up, looking at my y values. And there's no stopping point. My zeros is when it crosses the x-axis, and it crosses here at -2, but it's just touching. So that's going to be 2 of the same solution. And it goes through the x-axis at 1. It crosses the y-axis at -4. If it's an intercept, we want a coordinate point, so it's 0, -4. I'm not going to have any absolutes because it's going all the way down to negative infinity and all the way up to positive infinity, so there's no absolutes, but I do have relative maximums and minimums. So I see it's got a high point here. So this is a maximum, which is at -2, 0. And then down here, it's a low point, which is 0, -4. Last thing we've talked about is our intervals of increasing and decreasing. And if it helps, draw your dotted lines every time something new is happening. And again, both of these are x values. It's going uphill here, so it's increasing from negative infinity to -2. Then it's decreasing from -2 to 0. Remember, x value is not y. This x value is 0, -2 to 0. And then it goes back up from 0 to positive infinity. And to separate these, we put this sign right here, which means union or and. So just to separate it. One more example, we have a quadratic function. Our domain, x values, it's going from negative infinity to positive infinity. I'm looking at my lowest point, which is right here at -4. So my lowest y value is -4 to positive infinity. Because it reaches -4, it's going to get the bracket. Then we look at our x values, where it crosses the x-axis, and it's at -2 and 2. And then our y-intercept is where it crosses the y-axis, and it's here at 0, -4. Absolute max and min, it doesn't have an absolute max because it's going up towards infinity, but it does have an absolute minimum here at -4. We don't have any relatives. And then intervals of increasing and decreasing. Again, if it helps, draw your dotted line. I see it's going down. So it's decreasing from negative infinity to 0. And then here it's going up from 0 to infinity. So these are how you find characteristics of functions.